So this is another customer of ours, Carl Meyer. Has anyone heard of Carl Meyer?
I don't think.
No, I didn't either. So Carl Meyer makes machinery for textile production. So a completely different industry. And they have a large, large share of this market. So their machinery produces fabrics, anything from lingerie to car seats. And like other industries, they are in a competitive industry, so they always have to push what their machines can do. And so they looked at our technology to see what it could offer them. And particularly, they wanted to know that the business requirements at the beginning of a product development were met, again, early in the cycle. So we applied it to, or Carl Meyer applied our technology to two use cases. So the first one was threading a needle. And I imagine most of you have done this by hand. I did this. I remember helping my grandma do it when I was a child. So now this is done with high-speed machinery. And this is the machine that Carl Meyer was designing. Here the requirements are high-speed thread positioning. You have a high accuracy required. They wanted to look at different architecture possibilities, completely different designs. And there's a serious design challenge here. So this is what their table of product requirements looks like. Right? They have a list of requirements that they may have to make sure the product meets. Here are the different concepts that they wanted to examine. This is their actual current design, and it's done with pneumatics. It runs at 900 RPM. So the design challenge is trying to increase this speed. Concept two has a belt system, a single motor, and concept 3 has 3 motors. So the simulation was done using a tool called Simulation X, and they prototyped and simulated these 3 concepts. They used high-frequency modeling. It was a multi-domain, multidisciplinary simulation, and they implemented it in an object-oriented way. It's a German company, by the way. So this is ultimately what the simulation model looks like. They've got the 3 variants. They choose the RPM that they want to test, and then they run the simulation and 3 different branches, and they see if the requirements have been met. So this is the MDSC interface that we saw before. Now they're going to try another variant. See if that one satisfies the requirements. Now this one also failed at this speed. Finally, out of these concepts, only the third one was successful. But it was too expensive. you can see the different requirement, the cost requirement is broken here. So this is the sort of thing that allows the system people to understand what it will cost to reach a particular performance level. Okay, the next problem they looked at was a spool. And here again you can see a old-fashioned spool before modern technology and the kind of an industrial spooling machine that they use. So the challenges here are you want to go as fast as possible. You don't want to have a breakage in your string, and you want to have a smooth speed up, smooth start down, shut down, and then you want to look at what happens if you actually do have a break. You want to have a fast stop after a break, and you want to minimize the damage. So the main engineering challenge here is that the dynamics change as you get more and more thread on your spool. There is a dependency on the dynamics on how much thread you have on it, which is constantly changing. This is just a diagram of their model. I'll skip through it. This was the model center model for this use case. They can try different designs here, evaluate them, and also graphically see what the designs look like. See the shape, and then when the analysis finishes, they can see the performance. Skip this one. So, to summarize the benefits of applying MBSE and linking it with simulation, you can have an early stage concept evaluation, and you have a consistable, traceable, and integrated requirements management. Right? When you run your simulation, you can see right away if it met your business level requirements. We looked at the different disciplines we looked at. Cost and performance,